Hello everyone, this is Erlin from the Experience Research Lab. Today I will show you how to read the conjoint analysis output in SPSS, which I've already done in the previous video. If you are new to conjoint analysis, please feel free to check it out before or after watching this video. So conjoint analysis requires two different files of dataset. One is for the orthogonal plan, the other one is for the data collected from the subjects in observations or respondents in surveys. Here you can see how an orthogonal plan looks. If you want to know how to create it, please check the other video on generating orthogonal plan in SPSS. In the meantime, let us see the plan created for a carpet cleaner. It comes with several variables, including the factors or attributes considered for the cleaner. They are the package, brand, price, seal, and money-back guarantee. Each factor has two levels or more. The package, for example, has three levels: package A, package B, and package C. In this plan, there are 24 cards created. The first 22 are for the data collection, while the last two are for simulations. Out of the 22 cards used for data collection, 4 will be used for validation checks. These cards will be rotated and randomly selected to respondents who will need to choose which of the cards shown to them that they prefer most. And this is how the file for data collected from respondents look. It has 23 variables. The first one is for respondents' ID, while the last 22 for their preferences. To analyze the data, SPSS requires a syntax which specifies the files and their locations, the order of preferences, the subject's identifiers, the factors or attributes considered for the new carpet, and the details of the output. The output comes with a title, notes, if any, and information on the active dataset. The model descriptions highlight the factors and the levels considered for the plan. Additionally, it also mentions the relations of each factor to ranks or scores. As you can see here, the relations of the package and the brand to ranks or scores is discrete. It is because the values assigned to each level are equal. Meanwhile, the price relation to ranks or score is linearless because the higher the value, the lower the preference score. In other words, the relationship is inverse. On the other hand, the relation of the seal and money-back guarantee to ranks or scores is linear more. The lower the value, the lower the preference score. The first table in conjoint analysis shows the utility or pathword scores and their standard errors for each factor at different levels. The level with the highest score is the most preferred. As you can see here, package B has the highest utility score of 1.867. It is the most preferred. The carpet cleaner from K to R is the most preferred because it has the highest utility score of 0.367. The lower the price, the higher the utility scores. In this case, the carpet cleaner over at $1.19 is the most preferred. How about the respondents' preferences on the seal and money-back guarantee? It turns out that the respondents prefer the carpet cleaner with a seal and money-back guarantee to one that doesn't offer anything. If you apply all these scores to respective levels and use simple conditional formatting and formula, you can get the total utility score for each card. As you see here, card number 15, which comes in package B from K to R at 1.39 and offers both seal and money-back guarantee, is the most preferred, followed by card number 13 and card number 2. Meanwhile, for cards used in simulation, card number 2 is more preferred to card number 1. If you take the highest and lowest utility estimates, you can calculate the range for each factor. For example, the utility range for the package is 1.867 plus 2.233 equals 4.1. It is the highest among all factors. Further, if you divide the utility range for the package by the total utility range for all factors, you can calculate the average importance. Again, taking the package as an example, the average importance is 4.1 divided by 4.1 plus 0.717 plus 2.216 plus 2 plus 1.25, which is equals 39.87%. That is to say that of all factors considered for the carpet cleaner, the package is the most important, followed by the price. The second table here shows a similar output. If you notice, the percentage is slightly different because the syntax uses the subject command. Nevertheless, the package and price are still the most important. The third table here is only for factors that use the linear command, price, sale, and money. The formula to calculate the coefficients of the most preferred level is pretty straightforward. Multiply the value with its utility score. The coefficient for carpet offer at $1.19, for example, is 1.19 times minus 6.595 equals minus 5.542. Looking at the estimated coefficient presented here, you can see that price still holds the key to respondents' preferences. To be confident with your analysis, you need a significantly high correlation between the observed and estimated preferences. Referring to the person's R of 0.982 and a significance level lower than 0.001, you can say that the preferences are highly correlated and the correlation is significant. To support your statement, you can also refer to Candlestone. How about the cards used in simulations? In line with the previous manual calculation in Excel, it also finds that card number 2 is the most preferred. Finding is consistent across the 3 probability of choice models, maximum utility, BTL, and logit model. The last table shows the number of subjects or respondents whose responses are against expectation. While the majority express a greater preferences for the cheaper carpet cleaner, 3 show the opposite. Some prefer more expensive cleaners. Others prefer one that doesn't have a seal and a money-back guarantee. There could be numerous reasons for this. One of the reasons is because they consider the package and the brand more important than the price and money-back guarantee. Other reasons might be the problem in sampling and data collection techniques. But let us talk about it later in the upcoming videos. For more insights into data entry, transformations, and analysis, including conjoint analysis in SPSS, please subscribe, listen, and watch. Our content is available in text, audio, and video. Thank you for being with me today, and cheers!